Welcome to myTectra tutorials. In this section of our videos, we'll be helping you with learning some of the most popular IT and business courses. These videos will definitely help you to upskill your technical expertise. Please like and share, and also don't forget to subscribe to our channel for more tech updates.
Okay, let us start with. So LDA was requested, and then what was requested is ROC. If I remember, ROC I have already completed. I will just revise that. And one more was AUC, area under the curve. Right? These three had said that if you can show. So let me come to LDA first. Where is LDA used? I had given you as an assignment, so let me ask. Any of you, where is LDA used? Dimensionality reduction, right? So one method I have already taught in dimensionality reduction, we actually went in good depth of it, was PCA, principal component analysis. And there is one more way of reducing your dimensions, that is LDA. Is it clear to all of you? PCA, if you remember, I'll just draw one part of it. So let me say what is the difference between them. So if you remember, we plotted an axis and we took projections of all our points on it. If I have to give in a nutshell, and we check that this was maximum. What was maximum? D1 square plus D2 square plus till Dn square. So we took the distances, and which was max of this, that axis we used to choose. That was our principal component one, right? Here, it didn't matter what was this projection from. Whether there was no role of y here, if you remember. Y was nothing here. I mean, you didn't need to worry what is y. It was just seeing all your projections on one line, right? In LDA, y needs to be defined first. What is y? Output. Thank you. Okay. So y needs to be defined. But by what I mean y, I'll explain you using a graph. So LDA is used for generally for classification. What is it used for? LDA is used when you have a classification problem, right? In classification, what do we have? Your y will be what? Yes or no, right? So let us okay. So now what do you understand by this graph? What I want to show here is, suppose your yes is green and no is red. So what I'm showing is that in your, say, in your traffic conditions and rain, this becomes traffic, this becomes condition. And suppose there is 1/3 dimension of rain. So you have to imagine these points as 3D. Okay. Based on rain conditions also, it may go up and down, right? So these are the 3 dimensions. Now, when you say dimensionality reduction, what do you understand? What do you understand by dimensionality reduction? You need to reduce the dimension. Why? How? How? Like in PCA, what do? We take the information from all the dimension and we try to take it in its projection on, say, PC1, PC2, PC3, right? Explained yesterday also. So now here in LDA, also we are taking projections, okay? But the way of taking projections is different than PCA. Is it clear? In PCA, we take projections, right? I said max of D1 square plus D2 square. And there Y was nothing. I didn't draw anything like green and red there. I didn't say it was only for classification. I just said this is your X. There are 10 dimensions. You can plot it on one dimension and that will be a PC1. Perpendicular to it will be a PC2, etc., etc. Right? Here, when we start the dimensionality reduction, what I'm saying, please understand this. When we start the dimensionality reduction process in PCA Y is not looked into. Y doesn't matter, right? In LDA, Y matters. Okay, so when we are doing dimensionality reduction, we need to think about Y also. That is the difference between PCA and LDA. Okay, so suppose I want the information of 10 students into 2 students. Okay, does it matter whether the students are male or female? Does it matter whether students are, say, coming late or not coming late? There is no bifurcation here. It is 10 students. I want the information in 2 students. But suppose I am doing LDA. In that case, this 10 students, I will also check whether they are male or female. Okay, that information becomes important for me when I'm doing dimensionality reduction. Okay, so LDA, that's why I said, is generally preferred when you have a classification model. So here your Y is defined, right? That Y information is required for a dimensionality reduction. That is one difference. Okay, so why is it required? Why is it required is, so if you remember, like in this case, if you draw a PCA, it may look something like this. And then you will take the projections on this line, on the black line, right? In LDA, you can imagine some axis like this. Okay. What it will also try to do is whether the projection on that axis, listen to me very carefully, whether the projection on that axis is able to separate your, is also able to separate your see, it is 2-dimensional, so it is looking simple. I'm saying about multi-dimensional. In that case, this curve, this line will not be easy. You need to find that exact line where this kind of bifurcation is also seen. Are you getting the idea? So when you're doing LDA, the difference is when we take the projections, mathematically we try to see, it's like SVM, if I can simplify. If it's like SVM, where you're even on the projection, your classification is also happening. Okay. Now when this axis will become your principal component. So that is the difference between LDA and PCA. Are you all getting the idea? So a PCA, Y information is not required. In LDA, Y information is required. Why? Because when it takes the projection of each point on one axis, in that axis, it will also try to see, apart from the distance variance, it will also see whether it is able to differentiate the red and green dots properly. That is what is LD. Is it clear or not? So suppose this point will have a projection here, right? Suppose we draw something like this point. Okay, yeah, I think this will be a good example now. Suppose we take this line. Are you understanding when I'm saying this line? It is a projection on which axis we have to take. Now, if you say take the projection on this axis, what will happen? Let me draw it again. Instead of this line, right? Suppose I took this line for my projection. Okay. So what I said, I will just remove x1. I will keep only x2. Suppose that is how I reduce. So what will happen? This line will get, this point will get projected here. This one will get, this will here, this will get, this will also get. But your red lines also will come here. So here your red also will come here. Are you getting the idea? So this will not be allowed by LDA. Why? Because you're overlapping a lot of green and red. I think this will give you a better feel now, right? But in PCA, this was not the case. It doesn't care whether you're red or this. It just cares that your distance between your endpoints should be maximum. Are you getting the idea? So that is the fundamental difference between LDA and PCA. Okay. Okay. So this is about LDA. You can read more on it, but it is as this as this. So in interview, if people ask what are dimensionality reduction techniques, you will say PCA. Then the question will generally be on PCA. Let me be very clear. Most of them will ask you on PCA. Why? It is more generalized. In LDA, it becomes one more restriction is that you need to separate your yes and no or your classification. So why information becomes important, right? Okay. So you will say LDA is also another method. In LDA, information of Y is also required. In PCA, Y is not required. Okay. No. So I just told you, right? So suppose what data is this? What are the three data here? I told you that, right? So this is say traffic, conditions, and rain. Do you remember this example I'm giving in classification? This is your traffic, this is your condition, this is your rain, right? These dots will be there. So every point has three information: traffic, condition, and rain. Today, what is the traffic condition? What is my condition, and what is the rain? Right? So 3 points you have. These 3 points are represented by year. When you're doing PCA, you don't mind whether that day class happened or not. Right? But here you will also see whether that day class happened or not. And based on that, you will see. So your grouping is not done.
Some cases of your walking green, everything green. Some mixing, this direction also, they can mixing that also.
Yeah, so it will try to see that axis. The machine will say check that axis, which reduces the mixing. Overlap is I just showed you, right? This line, if you go on tilting, at some point you will see that the projections are there, and in that projection the overlap is the minimum. So it will choose that as the principal component one. Okay. So I have done some research on this also. So people say LDA is better when you use for classification, and LDA is better way to take information. But my research proves otherwise. PCA is much better and more advanced. Even I was using one paid software. So one company called Aspen. Have you heard about it? Aspen. No, it's a very big company. So Aspen Technologies, they were trying to sell my company the software. So that was fully GUI software. So in that software, they were doing pre-processing using only PCA. Okay. Why? Because PCA has been proven to be better. So that software was a paid software. So I had done a lot of research before buying its license. We already had some licenses. They were trying to sell us their machine learning product. But then later on, we found out we had done much more advanced work than them. So we didn't buy that. But for that, we had to do analysis. So in that, they had inherently taken PCA, not LDA. Is it clear or not? Why? Because PCA works on regression also, etc. and all. Okay, so this is about PCA. Next, about ROC. Where is ROC used? Interview question. In fact, when I started this, I told you there are 2 interview questions. Where is ROC used? I explained ROC after logistic regression, if you remember. There was a concept of threshold there. In logistic regression, didn't I tell you this here? I remember I taught ROC and I said AUC is related to ROC, so I want you to do it as an assignment. Okay. Anyways, don't turn pages. If you don't remember, let us revise it. So it's good for you. I remember specificity, sensitivity we discussed also, right? Anyways, so logistic regression, if you remember, was a sigmoidal curve. We tried to fit a sigmoid curve. Yes and no, how will we separate? Suppose this is yes and this is no. Then we will fit a curve on that, right? So, but anything below this threshold will be no, and anything above this threshold will be yes. So what was this threshold here? Okay, do you remember logistic regression, unlike tree-based models, gives probabilities, right? It gives probabilities whether it will be yes or no. 0.53, 0.63, 0.73, it will give you those values. So if the probability is 0.63 of yes, what does it mean? So traffic, conditions and rain, these three conditions I am giving you. Today the traffic is high, conditions are low, conditions are healthy, rain is not there, right? So in that case, you need to predict whether I will take a class yes or no, right? In Gini index, in decision tree, it was based on the splits, Gini index, entropy, etc. In case of logistic regression, instead of clear-cut split, it will give you probability of yes and no. So it may give you that probability of yes is 0.63 and probability of no is 0.27 or 37? 37, right? It will give you this, right? Now, if this is giving you probability, right, we need to keep a threshold. So if I say threshold is 0.5, threshold is 0.5, it means what? Whoever is above 0.5 will win. So here, if threshold is yes, is 0.5, then yes will win. So your model will give you the answer of yes. Suppose if this was the case that this was 0.53 and this was 0.47, then your answer would have been no. Is it clear? But the parameter here is threshold which we are setting. Okay. So every time it goes as an input to your logistic regression. You can look in Skykit in that when you are calling the model, you can set your threshold also. So by default, it is 0.5. Okay. But we may have to reduce it sometimes. Why? 0.47 is also on the edge. So what is good for you? If it is my probability of taking class is 0.47, would you rather risk coming to the class or not risking coming to the class? You may risk coming to the class. Why? It is okay. You are conservative. Your recall is high. That, okay, in case he takes the class that day, at least my recall is high. I mean, I have been in the class because that is more beneficial to you, right? But so it becomes tricky now. The threshold, ideally in ideal world, should be 0.5. But now, based on your preference or based on your testing and training data, you will play with your threshold between 0.4 and 0.5. Are you getting the idea? If you want to be more strict, no, I will not go to the class unless I am very sure, then you may increase your threshold to 0.55. Only if the probability of yes is above 0.55, I'll go to the class. Are you all getting the idea? Right? So threshold is one model parameter. Is it getting, are you all understanding what I'm saying? So that is why what it is trying to do is, okay, let me ask you one question now. If threshold is 1, what is the value of threshold? 1. Okay. How many true positives will be there? If threshold is 1, how many true positive will you get? All are true positive, because if threshold is no. Yeah. I'm saying threshold is 0.1.
Everything will be.
So your true positive will be 0 here. So your true negative will be very high, right? And your false negative will also be very high, if you can see. Because many yeses will go to no's. Are you getting the idea, right? So in this case, what we do is, in ROC curve, we draw the graph between TPR and FPR, true positive rate and false positive rate. Okay, so online you can just look what is the formula for true positive rate. TP upon TP plus
False.
negative, correct. Good. Okay, so basically the way to remember is false negative means what? What does false negative means? It is very simple.
Predicted as no.
Right. The second N or yes here is determined by the model predictions. So negative is what? It means model has said no. False means what? It was yes, but model said no. Right? So basically TPR is nothing but TP, how many you predicted correctly, upon how many you should have predicted correctly. TP plus FN means what? Total positives actually it was there in your. Similarly, false positive will be what? FP upon FP plus false positive. You can look online. False positive. True negative. Why true negative? Why true positive?
True negative.
Why true negative? Suppose if I take true negative here. What does true negative show? What is the formula online? False positive. TP upon FP plus TN.
FP plus T.
FP upon FP plus TN. Okay, so what does it indicate? What is true negative here? What is true negative?
Predicted no and it's not
Actually no. And what is false positive?
false positive is no. Predicted no and actually yes.
No, you're saying the ulta. FP means what? Model has predicted positive, but actually it is falsely predicted as positive. So actually it was no, but it was predicted as yes. Okay. So here we are checking how many false positive you are giving out of the total yes, total no's. If you see FP plus TN will be the total amount of no's in your sample, right? Out of that, how many you were predicting it false positive, right? Now suppose threshold is 1. Your threshold is 1. What will be your TP and F? What will be your TP upon TP plus FF? It will be 0. So this will become here. This point will become here. What about false positive? If your threshold is 1, what will be your false positive?
Maximum. False positive.
Mm-hmm. How many positives will you give as prediction if your threshold is 1? 0. So how many? All the positive. You will not give even a single positive prediction, right? So what will be your false positive? True positive will be 0. What about false positive? It will also 0 because your model will always predict no. Whether this person has diabetes, no. Whether he will take the class, no. Because your threshold itself is 1, right? So this will be 0. What about the case when your threshold is 0? Threshold is 0. 1. Right? So if you see, this is the line where your true positive and false positive will be equal. Okay? And what is there in between? The values of true positive and false positive. Here it will be 1, here it will be 0. First is this. Okay. Now let us take a point. What do you ideally want? Your false positive should be very high. Ideally, in your model, you would want your false positive to be maximum, correct? So Karthik is saying yes. What about others? In your model, would you want your false positive to be very high? False positive should never be there. Ideally, you would want it to be 0, right? So ideally, you would want your true positive to be 1 right? But your false positive to be 0. This is the ideal point. Correct? Are you all getting the idea? This is your ideal point when 1 comma 0, where your true positive is maximum and your false positive is 0. Because it is on the 0 axis, so it is 0 false positive. All of you are able to understand. So, if you do this analysis where you will change your threshold values, 0.6, 0.5, 0.4, you will get a combination of TP and FP, right? So, you will get some curve like this. Okay. Ideally, you would want your curve to be like this. Ideally, you would want your false positive to be 0. Okay. And your true positive to be 1. So ideally, you would want your true positive to be always 1. Okay. So this, every point should come here. Every point after, so don't misunderstand this line. What I'm saying is, for every value of threshold equal to, you should get your points here, right? But what will happen is, you will get some point here, you will get some point here, you will get some point here, you will, it is ideally it will not be the case. You will always get some false positive, right? So this curve which you are getting, where you are changing your threshold and tracking your TPR and FPR, is known as ROC curve, receiver operating characteristic curve. Is it clear? Okay. And what is AUC? Area under curve. So the area under this curve, is your AUC, right? Now you may ask, true negative also should be maximum. Yeah. So what I want you to understand now is, suppose you have having one more model, say a logistic regression model, where you change your sampling data. So now it's a new model for you. So you will now fit with different threshold another model. So suppose that model, if you vary the threshold, it becomes like this. Okay. If you vary the threshold, it will come something like this. So in this case, which is a better model? This one is a better model, or this one is a better model?
First one.
First one, the black one.
Yeah.
Why?
It's closer to the.
Yeah, it's closer to this ideal place. Okay, so as I remember it this way, as close you can be to this line, you have to be. Okay. In why they made AUC, suppose your machine, obviously you don't want to go, see, this becomes a manual process. TP, FP, recall, accuracy, recall, precision is one mathematical way. Are you all able to understand what I'm saying? So in that case, you can code, if my accuracy is greater than 0.9, I will choose this model. If the maximum accuracy model is my best model, that you can simple code like that. Whatever 5 models you have met, maximum of that is this. But if you have to make graphs like this, and then you have to go and check which, it doesn't make sense. Then there is no machine automation in that, right? To make it automated, they have concept of AUC, area under curve, which will have more area under curve. If you calculate the area under curve, suppose this is this line, this black line will have more area under curve, and this, as you go here, the square one will be having the maximum area. So it becomes very simple. The machine will make this graph, will calculate the area under this curve. The one having the higher AUC is the better model. As simple as that. Okay. So that is why the concept of ROC and AUC. Okay. So now my suggestion to you is, you concentrate on accuracy, precision, and recall. Okay, that is more mathematical or statistical way of looking at which is a better model. ROC, AUC comes under more of graphical way of looking at things. Is it clear or not? Yes. Right. Initially, when you're developing your machine learning or data science expertise, I will say rely more on the mathematical or statistical part. Okay. visually it becomes easier, but I don't want you to go through that easier process now. Try to understand with mathematics, with process. Okay, this value is higher, this is lower, this is higher, this is lower. Graphically, you can see and tell me, okay, this blue line is better. Maybe if the same was given to you in accuracy form, you need to do more analysis. Recall is better, precision is better, etc. Are you all getting the idea? Okay.
But in a company, we can show anyone.
Company, no one damn cares about what you are doing. The company cares about what model you are giving. If I am asking you whether I should come to the class today or not, I am the company. I don't care what analysis you do. Unless I am your boss, I will ask, okay, what is your way of doing? But the company will never ask what it is. Your CEO will never ask what is the method or how did you come upon it. Your job is to do that. You have to give that this is my prediction. You should, I go to presentations, and in my previous company, I never used to even say what method I've used, what I've used. I said this I've done data crunching of this, and this is the prediction I'm getting. If I go and explain them all these things, this is an art you will learn when you go in offices. You don't need to show them what method you have done. Why do you need to educate them? It is your work which you have to do. Okay. In fact, even if I am your lead and if you are experienced, say 2 or 3 years, even I will not ask you all this. I will ask you, if I trust you or I feel you are a good data scientist, I will ask you which is the best model. You will say this is the best model. Okay, give me the pixel. I will use it. Yeah, if you are not experienced, then I will look into all this. Have you done all these studies? How did you select the best model? I will ask all this question. Okay. Is it clear or not? Okay. So, as requested yesterday, I have completed that 3 parts. Okay. So, that's why last time maybe you're not remembering, we had done a study on ROC. And then I said, you look into AUC. So AUC is a small part, very under the curve, that's it. And I did you PCA. I asked you to do LDA because I wanted you to feel what is the difference between them. And maybe you would have come back to me. Okay, this is the difference. Here you see why, you don't see why. The projection style is different. It's like Gini index and entropy. Both are trying to do the same thing, trying to see the impurity in your data set. But the methodology are different, the formulas are different. Similarly, LD and PCA, the methodology is changing, but the way of reducing the dimension is still the same. It's by taking projections on one axis. Is it clear? Yeah. Okay. Okay, so let me start with the new part now. Can I start? The AI part, artificial intelligence part. So now with AI part, what do you understand by artificial intelligence? What do you understand by artificial intelligence? Say something.
You can say robot.
You can say robot. Okay. Try, what is your definition of AI? अरे कुछ तो बोलो.
Based on algorithms.
Based on
Algorithms.
algorithms. Machine to do your work. Okay. What about you, Shilpa? Say something. What about you?
Machine itself improves by giving the data.
Okay. So he has added to you. He's saying machine will also improve. Okay. What about others? So Prithvi, you may as well as say, what do you understand by artificial intelligence?
No, teaching machine to do things. That's it.
Teaching machines to do things.
Yeah.
Sorry, teaching machines to do things. Sorry, my handwriting is bad. Okay. So what is ML then? Machine learning. We have completed the course. Teaching the machine,
Train the model.
Training them.
training the model,
Getting the best.
getting the best. So, can you see a overlap or
Yes.
can you feel that? Till now, when you had started the course, you would have felt AI something out of the world, like robots and all. But if you see, ML is also AI, right? What is ML is basically, so if you remember, I started the classes by saying AI, ML is a part of it, right? Can you feel it now? Your data set, last 6 years or 10 years data, you have made your machine learn that data set using different algorithms. Now that machine will take decision for you. Today, should I take the class? Yes or no? Previously, it was like today students may not come, let's say no. But now it will be some statistics going on and it will say yes or no, right? So your predictions, machine is making the intelligence for you, right? So previously, we are doing machine learning every day, as I said in the initial classes. How much time? Whenever we speak to someone, we do some machine learning, right? Our brain has done some learning. How to speak to her, how to speak to you, how to speak to you, which language I should speak to you. I can speak to Hindi with whom. So all this is machine learning. My brain is learning that, right? All this information now I feed it in a machine. So it becomes artificial intelligence, right? So machine learning is a major part of artificial intelligence. Can you feel it, right? Now, along with it, in machine learning, even DL should come. Deep learning should come. Okay. Deep learning should be a part of machine learning. But this lingo keeps on changing. Okay. There is no international standard for definition of ML, AI, and DL till yet. Are you all getting the idea? So in industry, how it is perceived now is, I'm saying with respect to industry, not in the conventional way. In industry, AI is this part, ML is one part, and DL is another part. Okay, in industry. So when you come to my office, I may ask you, do you know machine learning? So when I ask you machine learning, actually it should include deep learning also. But now in industry, when they ask you machine learning, they don't assume about deep learning. Is it clear or not? So in industry, the definition is going this way, that ML is separate, which we have done till now, and DL is something separate. Okay. So many jobs, they will also say, we want ML skills like classification, regression. You should be able to understand pandas, numpy, etc. And apart from that, preferred skills, and they may also ask additional skills. You should know DL also. Are you all getting the idea? This is how people are posting jobs. Okay. So deep learning is something different and ML is something different as per industry. You may find some YouTube videos where people will define AI is DL and inside that ML also. Okay. So this is not making any sense. Okay. So for us, for our class, let us keep it this way. AI is ML and some part of DL. Also, it includes other parts. So other models are also there. Okay. It also includes IoT, Internet of Things, how you do wireless technologies, etc. It also includes that. It also includes, as he said, robot. Okay. Now, when I say robot, suppose in industry I put a robot which can say, pick my bad, say if I'm making water bottles and there are some defects in the line. So if I, instead of one person manually seeing it and removing it, I may put a robot, and that robot may have some sensors and it will keep on checking, okay, this shape is not right, I'll take it out. You may have seen in videos and all, right? So that is also part of artificial intelligence. But if you feel the word artificial intelligence, actually it is not artificial intelligence, it's just automation, right? But yeah, if you have some sensors inside it, Internet of Things, which are looking into, say, the size or color of the bottle which is coming out, right? And based on that sensor data, it is trying to, it has to get triggered, right? So suppose I'm making red color bottle and in between one pink color bottle has come. the machine will sense, okay, pink has come instead of red, let me pick this and put it up. It is artificial intelligence. Okay. So are you now getting better feel of what is artificial intelligence? Is it clear or not? Right?
The robot is comes from you.
No. Robot is a different part altogether.
It is different.
IoT is Internet of Things. So suppose you are there, okay. Suppose this day, like cloud is your Internet of Things. Why? Your watch. Suppose previously you had data in your watch, right? You would have to connect this watch to your machine through a wire and then transfer your data. Now this watch is connected. You have instead of wire, you have a Bluetooth or Wi-Fi dongle inside it. It is connected to internet, right? Now using internet, it is able to take information and get send information on cloud. So basically, it gets patched up with your mobile app. So your working steps, that data is being transferred real time to cloud, and from that cloud, your app is getting updated. This is how things are working. So your watch is now connected to internet. It has become Internet of Things. Is it as simple as that? Are you getting the idea? So in why I'm saying this, previously in industry, all the sensors were wired. All the sensors were wired. I come from manufacturing, so I have seen this completely. So suppose I'm measuring a temperature now. What used to happen previously, 20 years or 30 years back, I had a gauge there. So let me draw it for online people. So suppose this is one line where I say gasoline is flowing. Okay. And I need to check one temperature here. So previously I used to insert a temperature here and I used to see a gauge here, like a thermometer, right? I used to see, one engineer used to come, he used to check, okay, the temperature at this time 14 hours, temperature on that pipe was 30 degrees Celsius. Okay. Next phase of industrial automation came, we connected this to using wire to a computer. So instead of I going and checking the gauge, there is a digital thermometer, digital blood pressure measurement. So now here my 30 degrees Celsius is showing on my screen. So real time it is changing. Are you all getting the idea? This is the second phase of automation. Now third phase has come that we will not have this also. We'll have this directly connected to internet. So not only my data is coming, it is also getting. So now, okay, let it put it this way. Second phase, you had to go to the console and look at the data. Now in this phase, I have an app. I have a mobile app or tablet with me. I can go anywhere. So Ambani can sit in US and can see what my temperature is there in that. So this is what is smart homes. This is what is smart this thing. Your locks have become smarter. Your TVs have become smarter. Why? Just because you have connected it to internet. So this is Internet of Things. Can you see the evaluation? So now in industry, they have a term called Industry 4.0. Okay. Industry 4.0 means now fourth phase of industrial revolution is. So in this class, in AI classes, okay, the talks I am making currently, to you currently is not some story I am telling you. Okay, these are actual talks which will help you understand what is artificial intelligence, first of all, so you can converse with anyone, right? And also make you understand where you stand or where you want to go ahead. Okay, it is more of, say, introductory classes, the AI part. Okay, it will not have much of algorithms or something. It is more of understanding how AI works. Okay, why it is so tough, or what field you want to go, etc., etc. Okay, so in these classes, I will first give you in-depth understanding of neural networks. That will be the takeaway for all these classes. Neural networks. I will give you this. Okay. I will give you what is the state of the art. State of the art means what? What is happening in the AI world. Okay. So the two most word used in AI is computer vision and NLP. Image processing also people say. Computer vision means image processing and NLP. Okay. So I will take one case study each on computer vision and NLP. I will explain you how these things work, which are the packages required. Okay. So you will have a good feel of it. Okay. So now when you go for companies interview, you will say, I know this part perfectly. DL part, I know how it works. I know what are there inside it, but I'm not an expert in this. So yesterday also I said, never claim that you know AI completely. Just say, I know the ML part of AI very nicely. You can, so even in fact, when I was discussing with him, when I take interviews, I ask the people, are you more comfortable in regression or classification? Even in that, we go to that level. Okay, he says classification, I've solved good projects on classification, then I will ask him only questions on classification. See, all this talks which I'm giving will help you in being more confident for interviews. Okay, so this is how you will approach. And many of my students have approached it this way. So when they go for interview, they will say, I know everything about ML. Okay. On DL, I have done few case studies on CV and NLP, but I can learn more on it. I know what are the tools required. I have used it, and I know what can be done. Is it clear or not? Why? Because DL, people have made fun of it by asking in resumes, in job profile, they will say you should know NLP, you should know computer vision, you should know ML. This is not humanly possible. These are very vast topics. Someone who has worked 3 years on computer vision will have a different understanding altogether than someone who has just started on computer vision. Okay. So as freshers, you should also always claim, I know computer vision, but I will learn more onto it. So usually the job process goes like this. People join and start taking projects on ML. Okay. And within the organization, they move towards deep learning. They start learning more about it. This is how they update their skills, etc. Is it clear or not? Right? So here, one key thing which we will be discussing is neural networks. So I wanted to cover that topic. Till here, is it clear to all of you what is AI? Are you getting some feel of AI? Are you feeling, I mean, when you started the course, you may have felt AI is something different, ML is something different. Now, currently, you are also seeing maybe DS is data science also includes ML. If I make one more circle, maybe ML above that will be data science. So a data scientist will know more about pre-processing and post-processing. He may also know about big data engineering, a data scientist, because he knows everything about data. Okay. ML is the person who will just tune the model for ML. Are you all getting the idea? So that's why I said typically in a ML course, I should just teach start from regression. And this is what I have decided now for further batches. I will not, if they have enrolled for ML, I will now start from directly regression.
Then how it will manipulate the data?
So that becomes part of data science actually.
That is if they go for interview, you will ask no.
That is why I was teaching here. But what is happening is now people, like when I said one weekend I will take more on DS. So people are started doubting, or you all think, okay, data science is so short. It's not that. We have been doing data science. I have spent a lot of time explaining standard deviation, how you need to look into it, what is mean, what is average. Actually, all this is part of data science. I hope you have become so knowledgeable to understand, or no one can fool you. So myTectra guys may have fooled you initially. I mean, many people say this course, that course, what is that course? But now you are educated enough to understand what is data science, what is ML part in it. Can you feel that ML is a part of data science? Data science is more about pre-processing, post-processing. Okay. And also I will say a data scientist will have more knowledge about machine learning algorithm also. So suppose I have a ML engineer, at best he can just tune the model, or he knows in and out, but a data scientist should have more information about the algorithm. Okay. Especially the statistical part. So now when I do a data science class, what I meant is I have been doing that, but I will add more into it with respect to p-test, t-test, etc. So if you remember z-score, that is a typical data science thing. That's a pure statistical. It has nothing to do with machine learning. Even your PCA is nothing but data science. It's not machine learning. Is there anything machine learning from there? In PCA and LDA, is the machine learning anything? No, it is just collecting information. How you are collecting information, that is mathematical manipulation. Okay. Now coming to AI part. AI part is a ready machine learning. So the pickle model which you have made, that is your artificial intelligence. You have given all the information to that point. So that becomes your artificial intelligence. Is it clear or not? So till now, your cameras were just looking at you, right? But now your cameras are also detecting your faces. If you see your mobile cameras, if you detect, it will detect the faces, right? That is artificial intelligence. How does it know that these are faces sitting in? Yeah, sure. In fact, in my mobile, if I put it in front of plants and all, it has started showing these are plants. This is detecting objects. This is a fan, this is a bottle, this is a face. Okay, so this becomes artificial intelligence. Okay, what is running behind that? That I will give a good understanding of it. So when you go for interviews, you are very confident. Is it clear or not? Okay. Artificial intelligence in this course, I will also give you a state of the art. I said state of the art. What do you mean by state of the art? What is currently happening in this field? Okay. What are all technologies being used by Google, Facebook, where it is used, etc., etc. So in fact, I have to give a presentation in second week of January in one very Fortune, maybe 100 company. They have called me. I'm going to give a talk on what are the technologies that will change on 2020, which are the most important technologies for 2020 and onwards. So I'm just collecting data and trying to make one good presentation. So all those information I'll try to give to you. Is it clear? That is what is artificial intelligence, what is happening in AI. Okay. So is the takeaway clear right now? I am not giving you false hope by saying AI also you should become an expert. No. AI, you know what is happening, what is there. You are confident if you are given a chance, you can work more on it and become good AI specialist. But your forte or taking best chances for taking a job is now in ML field. I'll not make two minds about it. Because regression, classification, etc., you cannot do it very well. Is it clear? Okay. So is it clear till here what is AI, what is all these things? Okay. Now let me start with neural networks. You may find a lot of technical definitions of AI, etc. I will also go through that later. I have a PPT ready for it. But have you got the intuitive feel of what is the artificial intelligence? Okay. Yeah. What is neural network? What do you understand by neural networks? You are studying. Okay. This has been going since 1950s. It became very special. Anyone? What is our human brain made up of? Neural means human brain. That I think you can relate. Brain. How does brain work? Neural. Perfect. You said something called neurons. What is neurons?
It's a cell.
Okay. Correct. It's a cell.
Neurons sharing information.
Neurons sharing information. Good. So you have all solved my problem. I think this is a key word here, sharing information. So when I'm saying something, it goes through your ears, okay? It reaches some part of your brain, and then that part, the brain communicates with each other using neurons, okay? So basically, a brain is made up of neurons, if you can understand that. and each neuron is communicating or sharing information with other neurons. Each neuron is sharing information with other neurons, correct? This aspect of brain has been mathematically coded. This aspect of brain, like decision tree, if you see, the tree is because of that split branches, if you can see, root is there and then you're branching. So it is inspired from nature. Entropy, etc. is inspired from nature. Similarly, neural networks is inspired by human brain. Okay, so what the scientists wanted was, I will want to mathematically code your brain. That was the inception of neural networks. What was it? I will like to mathematically model your brain. Okay, how will it model? It will make a neuron. Okay, the neuron will get somewhat. When I'm saying something to you, what is that for you? Information. What is that in machine learning term?
Weights.
Input, perfect. So a input is coming inside you, which goes into a neuron, and what is coming out of it? Output. You're registering something, or you're speaking back to me, you're answering back to me. That is an output, right? In between, what happens is that part it has coded in neural network using maths. Are you getting the idea? So here, what happens is you have more neurons inside your brain. You have more neurons inside your brain. The information goes to the first neuron, it goes to the other neurons, and you get the output. Okay, this is what is brain. Okay, now what is complication here? This neuron is not only communicating with this neuron, it is also communicating with each neuron. Okay, this neuron is similarly communicating with each neuron. This neuron is also communicating with each neuron. This neuron is also communicating with. Can you see the complexity here? Okay, now this communication which is happening is mathematically coded using activation functions. Activation function. Okay. So what happens is one input which I gives to this neuron will put it in an activation function, and then it will go with that activation, it will go this information to the other neurons. Is it clear? So there are different types of activation functions. Okay. Also when it goes, so suppose I am sending an information to Rai. Rai will give it to Karthik, will give it to her, will give it to you, everyone, right? When you are passing information, you are converting that into, using an activation function, you are converting it into some values. Okay. But when you are passing it to Karthik, you are also passing that value with some weightage. Okay, so you may pass some lesser information to Shilpa and you may pass with more weightage the same information to Karthik. Is it getting clear? Okay, till here is it clear? This weights, how much weight should be assigned, is what the machine learns from the training and testing data. It is same machine learning. Are you all getting the idea? So suppose traffic, rains and condition. How many inputs were there? Traffic, rains and conditions. 3 inputs are there. And what is the output from it? Yes and no. I think you'll be able to relate, right? Now this information, I am saying in your brain, there are 2 layers. There are 2 layers in your brain. One, and in each layer, I am only defining there are 50 neurons. How many? 50 neurons. So imagine this as 50 and second layer. Okay. So you are giving information of traffic conditions and rain. this each information is being communicated to each neuron, 50 neurons, and this is getting into 50 neurons. So every cell, if you see, is getting one traffic condition and range information. It will put it in the activation function, and with some weight it will give it to the next layer. Okay, this weights, and based on that it will predict yes or no, right? This weights which are being adjusted inside is nothing but done by the machine using optimization like gradient descent method. Can you now put related to a linear regression? In linear regression, we find that line which will fit best. R score is highest, right? Your error is least. Similarly, neural networks, what it will do? The weights which are assigned to each neurons, that will be decided by the machine so that your output yes and no is decided. Okay, this is machine learning. How it will do? It will do it using gradient descent method. It's simple. People have made it complex. Now, what is deep learning? If there is so this layer is known as input layer. What is it known as? Input layer. This layer is known as hidden layer. What is it known? Hidden layers. And this layer is known as output layer. All of you please repeat. Input layer, hidden layers inside your brain, and output layer. Right? Hidden layers. Hidden. It is hidden. It's not, you don't know what is happening inside. It's like a black box. I say something to you. What you are thinking, what you are doing, I don't know. So it is all hidden layers to you, right? If I am able to give input very nicely, then maybe it will get registered in your mind. If I am giving very slowly or I'm not communicating in your language, you may not understand. So it are all hidden layers, right? Deep learning is nothing but having more than one hidden layers. What is deep learning? Now, can you relate to the word deep? Previously, only one layer was mathematically very complex. If you see, each communicating to 50 neurons, that 50 neurons is giving results to output. So you have to adjust the weights of 50 neurons. Here, now with today's mathematics, you can have 50 hidden layers, 40 hidden layers. So that is why it is called deep learning. Are you educated now? What is deep learning? It is nothing. It is not rocket science. It is just pure neural networks where the hidden layers are more than one. As simple as that. People may try to give you some mumbo jumbo, but it is just as simple as that.
Does it make it more efficient?
No, it may also lead to, now I can speak the language with you, it may lead to overfitting.
Yeah.
Okay, so usually 1 or 2 is more than sufficient. Why it is required now more is because now we are doing more complex data. We are doing computer vision, which is an image. So next class I will explain you what is image. I will give you a good background. So you will understand it, what is the complexity. But can you understand here? So today's class I want you to remember neural networks is made up of input, hidden layers and output layer. If the hidden layers are more than one, it goes into the arena of deep learning. Why? Because there are deep learning where there is more mathematics involved inside. Okay. And what are activation functions? Activation functions are of different types. So maybe I will list it down to you. ReLU, sigmoidal, then tanh. These 3 are major ones. Okay. So what happens is if I use a ReLU function, it means what? I give you some information. Okay. You will put that information into a ReLU function. And that ReLU function will give you value between say 0 and 1. And that information you will send it to others. Okay. So how to convert that information? You have tanh, ReLU or sigmoidal, different kind of activation function. Okay. And you will assign a weight to it. It is as simple as this. Okay. Yes. So the same problems which we have solved using conventional machine learning. Even this is machine learning if you see. Yeah, machine is learning and adjusting your weights there. But in now in today's world, they have started calling it deep learning. But it's a part of machine learning. Now you can understand. The machine is learning. So the same problems which you have solved can be solved using deep learning. Okay. So you may ask, why not go for deep learning directly? It's not required. Deep learning may lead to problem of overfitting. Also, if you see, you require more data, millions of data. Is it clear or not? Okay. So this is about neural networks. Then I will explain you what is CNN, convolutional neural network, and artificial and recurrent neural network. Why it is required in image processing? Why it is required? What is TensorFlow? What is Keras? Why I am saying that you will also in the class understand that. So I have a full-blown classes on say computer vision. So I am taking say I am working on computer vision since last 3 years. Okay. So I know in computer vision exactly now in industry what all things are required. Okay. But that will be again a 3-month course or a 2.5-month course. Because a lot of things will go inside. Similarly, NLP people say it has not developed so much, but NLP also requires similar kind of effort. If you see machine learning, whatever you have done, you will require some effort now to sit, understand it better. I'm not giving you false thing that you have. I know you have understood everything. If you open Google now, you'll understand everything in and out. The only thing is now you need to sit, do it, case study. You will not have to go through that learning curve now. Now you are in the application curve. Similarly, here to reach the application curve, you will require a lot of time. Okay. Also, you will understand in the class when I say I will hire. Suppose I want someone working on computer vision. I will hire who has worked 2-3 years on computer vision. Why? Yesterday we were having a discussion. I may want him to come and first day deliver. For freshers, it will not be possible to come learn deep learning and start delivering me in say 1 month. Okay. For that, I will require some experienced candidate. So that is why when it comes to deep learning or something, people ask for experience. But machine learning, etc., I'm very sure you can get good jobs. Okay. But at the end of this classes, you'll be more confident. You'll know exactly what is there. Also, when you're communicating with your interviewer, you know what to say when. Okay. So this will be a very, help you in understanding everything and consolidating everything. What is TensorFlow? What is Keras? You'll understand everything. Okay. And I'll also make you do 2 case studies of computer vision and NLP. Is it clear or not? I think we'll stop here. Many people are also not there. So when they come next time, we'll have.
Thank you for watching this video. We'll be back with some more tutorials very soon. Stay tuned.